Hey, how's it going? So, man, this is taking forever. Come on. We need 16 seconds left. All right. Um, I let's look at the daily leak. Not daily. I already did the daily leak code, and I'm not doing it again. So let's see. But I know that I missed a weekly competition, which means that there should be a new easy one out. You done yet? All right, cool. Now I can close the tab. Close. Okay. Let's see here. So we will go, wait, algorithm is already selected. Status is to do, and difficulty is easy. All right, sweet. So go here. Exactly one consecutive set bits. Oh my God. Exactly one consecutive set bits pair. Well, those are words. Return true. You're given an integer n. Return true if its binary representation contains exactly one pair of consecutive set bits, and false otherwise. Okay. So I don't know, bitmask equals 3, CNT equals 0, while bitmask is lesser than or equal to n. If bitmask and n equals bitmask, I don't know what the order of operations is on that. Then CNT plus equals 1. Equals 1 if CNT, well, no, we don't have to do it that way. Return CNT equals 1. If CNT is greater than 0, then no. If CNT is greater than 1, then we can immediately return false. I don't know, there might be a more efficient way to do that. So if n dot bit count is less than 2, then continue. Not continue. What the hell am I talking about? Return false. I don't think any of these optimizations were necessary or helpful. Beats 100%. Okay, you know what? I can live with that. All right. Check good integer. You are given a positive integer n. Let digit sum be the sum of the digits of n. Then let sum square be the sum of the squares of the digit of n. An integer is called a good integer if square sum minus digit sum is greater than or equal to 50. Okay. All right. Trying to figure out how to do this. Return something is greater than or equal to 50, right? And then we're going to say for I in str of n. And then I kind of hate having to do it this way, but int of I, and what is square sum minus digit sum, right? And I'm just saying that we can do that in any order. I mean, you can move all the adds to the beginning and at the end. It doesn't matter. All the subtractions. It all kind of works out. So let's run that and submit. Woohoo! Beats 100%. All right. So let's go back here and... Okay, that is done, but we're going to say difficulty equals medium, and then I want the oldest one, please. Last submitted time. Just sort by number. What? How do I sort it by the number? Custom frequency, contest point, difficulty, question ID. That's how I sort it by the number. God, that sucked. Okay, maximize sum of device ratings, frequency balance. I don't want to be here all day, so let's just pick one with a high acceptance rate. Minimum cost to split into ones, part 2. Oh, it's a premium problem. You're given an integer n. In one operation, you may split an integer x into two positive integers a and b such that a plus b equals x. The cost of the operation is a times b. Return the minimum total cost required to split the integer n into n ones. Would you ever split it into anything other than 1 plus the number? Think if you had the number 2. Well, okay, that's a bad example. I really don't think that there's any situation where you would want to split into anything other than 1. Come on, take forever. I have an NVMe drive and 64 gigabytes of RAM and one of the, well, not the highest end, but I have a pretty beefy processor. And what? Hey! That German lesson is not released yet. You get off the screen. Okay, new. Okay, open in new Python file. Probably have something called Scratch. So Scratch 2. So let's say that we have a number for n in range 3 to 500, right? And well, okay, hold on. If you split it into something higher than 1, then you would have less left over to split, right? Let's think about it this way. If you had 500 and you split it into 1 times 499, then you would have to do that, well, it would be, the cost would be 500 times 501 divided by 2, right? That's if you split it into 1 every time, or what? That might be times 499, but you get the idea. That's the general idea. Now, if you split it in half, then that's going to initially double your cost, but it's going to reduce the number of times that you have to do it. Let's come back here. Is just a DP problem? The cheapest way to get from 1 to 2, let's see. The cheapest way, okay, so obviously the most expensive is going to be n times n, well, n plus 1 times n plus, it doesn't matter. N plus n to the third, whatever. Doesn't have to be right. Okay, so for I in range n plus 1, right? Now, obviously, dp of 0 is going to be 0. dp of 1 is going to be 0. I don't know. I honestly do not know. Okay, dp of 2 is going to be equal to 1. It can go up to 10 to the 7th. That's 10 million. Obviously, we can't check every single one of these, right? But maybe we can store, the bests or something. Linear search. Because there's going to be two of these that are going to add together to be the number. Like a naive solution for a smaller problem. But you know what? Maybe if I code it in an n-squared way, I can see a pattern emerging. Okay, so for I in range 3 to n, well, n plus 1, right? And what do we want? The cost is going to be A times B, right? So for A in range, I know 1 to I. And for B, well, no, B is going to be dependent, so it's just going to be I minus A, right? We're going to have cost equals A times B. But really, it's going to be plus dp of A plus dp of B, because the dependent parts are going to all right. One optimal set of operations. Yeah, but then you're going to have a pool. You're going to have a pool of things that you can draw from. I don't know if this DP solution is going to work. Is this really an easy problem? I think the pass percentage rating is a little bit misleading. That doesn't tell you how many people opened it and got it right or failed. That only tells you how many people submitted the question and then it passed. Okay, so 1, 2. Yeah, because you might have a bunch of 2s left over, a bunch of 1s left over. I have this weird feeling that it's going to be something like it only makes sense to split it into 1, 2s, or 3s or something. Xbox controller disconnected. Xbox controller disconnected, huh? Yeah, let's see here. So we split A and B into 2 and 2, 1 and 2. Let's see. Let's see if the answer is only split it into 1s and 2s, and then you're going to have 1 left over, right? I'm just going with it because, obviously this isn't even formatted right. Okay, so it's going to be 1s and 2s and then something. And so we're going to be decomposing it. So let's go def r of I, and we will do at LRU cache none. Right, so if I is less than 2, then return 0. Okay. And then we have choices. Our choices are 1 and 2. I'm hoping that that's right. Okay. So, yeah. So if I equals 2, then return 1, because we're done, right? Yeah, but we're going to have 2s left over. We're going to have batches of 2s. We're going to have numbers of 1. We're going to have count of 1 and count of 2, right? Count 1, count 2. No. There's nothing to do with 1s. And each 2 has to decompose on its own. So, yeah, you would never touch a 1 again. Ever. That doesn't make any sense. So you have I and count of 2, right? So each 2 would have to decompose on its own, which would be 1 for each pair, or just C2. Yes, now if I equals 2, then return 1 plus C2. So that is our base case. I still feel like there could be a 1. I still feel like there could be a 1 that would be worthwhile. Maybe I'm being stupid. Are you going to repeat this problem 10 million times and then each one of those 10 million times? It has to be 2. There's no other way. Yeah, I'm not actually sure that's true. I'm not convinced that that's true. Taking 2 off every single time. If there's one operation we can do it, we can step through 10 to the 7th one time. We cannot step through 10 to the 7th, even log n times. That would be too much. N log n is too much. So it's just always 2. Yes. Well, I might have to look at the answer because if this doesn't work, I really have no idea. So, you may split an integer x into 2 positive integers. Okay. So each one decomposes on its own. I was right. I was right at the beginning. I don't know what the hell I was doing for a second there. Okay, so if it's lesser than 2, return 0. If I equals 2, then return 1, right? What was I doing? I have no idea. I got confused or something. All right. So I think that our original idea was right. So path 1 is going to be, well, R1 is just always 0. So it's going to be R of I minus 1 plus, well, just I, because it's going to be the current I. Yes, okay. And then path 2, well, hold on. Path 2 equals path 1, right? Let's have it all. Well, no. We got rid of 2. You can always subtract 2. So it's going to be 2 times. Is this right? No. This is not right. It's going to be 2 times I minus 2 plus the 2 choices. I minus 2 and 2, which is just 1. So, like that, right? Well, that's assuming that these really are the two only viable options. And if it's everything in between, well, it would be symmetrical though. It would be symmetrical. And the only other choice would be maybe the center range values, but it seems like that's how you get the highest numbers, not the lowest numbers. Okay, so return just R of n, I guess. Unsupported type, none type, and int. The hell's none type? Where's none type coming from? Return min of path 1 and path 2. I think I figured out where the none type is coming from. Memory limiting. All right. All right. All right. All right. All right. All right. That's fine. Let's start where we started from again. So end of the third plus n or something for I in range n plus 1, right? Then dp of 0 equals 0, dp of 1 equals 0, dp of 2 equals 1. Okay. Hold on. I need that formula for a second. So we're going to say for I in range 3 to n plus 1. And the two choices that we are going to have, so dp of 3, not 3, dp of I equals minimum of dp of I minus 1 plus I minus 1, comma, and then dp of I minus 2 plus 2 times I minus 2 plus 1. You know, living by a highway is actually kind of annoying. All right. Now, hopefully this is actually right. Well, it got through 1,527 test cases. So I have a feeling that that is actually the trick. All right, sweet. List assignment index out of range. All right. If n is lesser than 2, then return 0. If n equals 3, then return... No, that's right. This is n equals 1. If n equals 2, then return 1. Where's use test case? Let's go. Oh God, that isn't even that big. What is going on? This is order n. What do you mean time limit exceeded? It can't run order n for 97,000? I just realized something. We're not actually reusing any values. Maybe memoizing was a mistake. All right. Problem is actually kind of starting to piss me off now. If n is less than 2, then return I. If n equals 2, return 1. Return min of r. Here, let's just copy it. Okay, it did get through 2000, so obviously this is right. If this doesn't work, I'm looking at a solution. Okay, we don't store anything. There's no array, there's no memoization. Return R. This is going to hit every single node on the way down. Every last one of them. Well, this is going to hit every other node. This is still n squared. There's no way that this is going to work. Wait, what? This isn't going to work. This is going to be even slower without memoization. Because, yeah, this is going to hit this. Is this a simple arithmetic sequence? Yeah, but I don't know which one is best. Like, if I knew that it were always 2, then, you know, fine. Here. Path 1 equals this, right? Path 2 equals this. If path 1 is less than path 2, then print I, comma, path 1 better. Else elif path 2 is less than path 1, else let's take a look. Return min of path 1, comma, path 2. Path 1 better. Paths equal. We need a larger test case. So let's say 38 is time loaded exceeded, right? So let's say 20. Now run. Equal, equal, equal. Is path 2 ever better? I just want to copy everything. Let me copy everything. Path 2. Path 2. If the paths are equal, when are the paths equal? If the paths are equal, then you definitely would want to select 2, because that's going to decrease the other number quicker, right? Yes. So for each of these, we just need to calculate whether the paths are equal. Five, 3, 5, 6. Yeah. Don't save. Okay, so scene equals set. This is not very helpful. So if I not in scene okay. Scene.add I, right? That'll probably help. Paths equal. Help me to figure this out here. So if we split this into 1 and 9, then that is a cost of 9, and then we have to decompose, right? But if we split this into 2 and 8, then it is a cost of 16. But look, 9 would decompose into 7 and 1, which is 14 plus 9. That's not 16. That's not. It's a cost of 7. Okay. Path. So my original thought that we always choose just to splitting by 1 is either always. It's either equal or always better. All right. Path 3 is just going to be 2, right? So let's say I equals n We don't need to iterate. It's going to be n minus 1 plus n minus 2 all the way to 0. Return n minus 1 times n minus 2 divided by 2, right? Just like that. Let's see, for 3, that would be two. Yeah, I think that's right. Maybe not. Muito melhor agora. Well, in this case. What is the minimum? The minimum is 1. How? How could something possibly be faster than that? You know what? I don't care. I don't care. I'm glad that the problem is done. Okay. That's interesting. And I'm a little bit annoyed at myself because that was my initial inclination, was that splitting by 1 was always going to be superior. I didn't guess superior or equal, but all right, okay. So yep,